Good morning, everyone, and welcome to the class. We are into the fifth lecture. What did we discuss in the last class? Do you recollect? What was the point of discussion? Are? What was the point of discussion in the last class?
Sir, de Broglie.
Sir, de Broglie. Okay, de Broglie wavelengths we were discussing. We were discussing matter waves, and we had seen some shortcut formulae for finding out the
Yes, sir, an electron, proton, neutron.
the wavelength, the matter wave, de Broglie wavelength for a fast moving electron or proton, which are charged particles, alpha particle, deuterium, deuteron, and all those things. And now we also saw it for a neutron, and we got the small formulae.
Yes, sir. Bohr quantization condition.
What?
Bohr quantization condition.
Bohr quantization condition, MVR is equal to NH by 2 pi. Great. So that is how good. So it seems that you have taken my advice and you have studied before coming to the class. That's a very good practice. And I'm very happy that you are doing it. And that will give you more confidence when you come to the class. Well, I said that even if today you would not have done that, it would not have made much difference because the topic may be slightly different and it may not require what you have read in the previous class. But it's always a good practice to study the lecture of the previous class. Now, what's the topic for today? First of all, tell me, did you get the sheets that I sent you? Both the sheets? Yes or no?
Yes, sir. Only matter wave.
Only matter wave. So, not the photoelectric one? You did not get that?
No, sir.
Okay, sir. I will again try, sir.
Okay, sir.
Anyways, you got matter wave, so I hope you can solve questions on matter wave. And the topic for today is what? Since we have done matter wave, since we have done photoelectric effect, and normally I do something else. But see, every day, every year, you do something new and you do something in a new way. So now this is the first time I'm trying this after matter waves, and I think that we will be able to relate it more effectively, or I should say after photoelectric effect, because from photoelectric effect we went to matter waves, and now we are shifting to an entirely not entirely different, but on similar lines, I must say. So I think that you will be able to relate to this more efficiently if I take this topic now rather than at last. And the topic is right here on your screens now. Putter 5, 6. So that's not putter. It must be part. A spelling mistake. Let us forget putter. So all this looks like Hebrew. So I'll just cut it off. The only thing that, I have cut off X-ray also, so I should not cut X. So the only thing that concerns us right now is this part. Oops, again I made a mistake. Why am I making so mistakes? The only part that we are worried about right now is putter for X-ray. X-ray, 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 X-ray. Do you know X-ray? Yes or no?
Yes, sir.
Heard about X-ray? Well, X-ray, 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 X-ray. Since you are going to be doctors, you would be using a lot of these X-rays. So this is the point where we understand what are these X-rays. Now, to understand X-rays, what we are going to do in this entire thing, we are just going to understand two things. In photoelectric effect, we understood intensity of light depends on the number of photons. Yes. Energy of light depends on the frequency of photons. As you can see, a similar arrangement is here right now in front of our eyes. In case of photoelectric effect, we have done an experiment, right? Similarly, here also, we are doing an experiment, and this experimental knowledge is going to help us solve almost 90 to 95% of the problems that are going to come in X-rays ever. The rest 5% will be in a different, will be coming from a different concept, and that concept will be similar to what we have done already, and that is why X-rays come into the picture. So this is Royinton's experiment. So what he did, obviously, you know that this is a vacuum chamber and all that, right? In photoelectric, do you have a cathode, do you have an anode? Yes or no?
Yes, sir.
The only thing was light was falling on cathode and electrons were getting released. Yes or no?
Yes, sir.
Now, here what is going to happen is something of similar, but probably ulta sort of thing. What I'm gonna do is, I have a cathode here. Can you see the cathode?
Yes, sir.
Then you see the anode,
Yes, sir.
and you see a target here. Yes or no? Shall I increase? Shall I what? Shall I increase this picture, make this picture bigger, and probably try to make more sense of whatever I am babbling here. And you must understand that you have to draw this picture so that you understand the concept correctly. So I'll get to here. Okay, this much will do, I hope. So you understand here, right? You have a cathode. Can you see the cathode?
Yes, sir.
You have an anode,
Yes, sir.
which is also written as target, anode and target. So the target is anode here. And then you have this black thing. Do you see is the target? Do you understand this target?
Yes, sir.
Then you have a very high potential difference applied here. Yes or no?
Yes, sir.
Now, can you tell me what is happening? Just looking at the picture, can you tell me what is happening here? Have you read this experiment, the Rowington experiment, before? Have you read this experiment before? I guess not. Looking at the picture, can you tell me? I hope you are drawing the diagram as well, a very simple diagram like this. Looking at the picture, can you tell me what is happening? What is happening?
Electrons are falling on anode.
How are electrons released? That is the first thing. Yes, electrons are falling on anode. How are they released? From where are these electrons coming?
From cathode.
From cathode. How are they coming from cathode? How are they coming from cathode? So you have to understand that. So okay, tell me. So far so good. You are going in the right direction. So tell me what else is happening. Cathode say electrons are released somehow. I don't know how. And then these electrons are falling on what?
Anode and target.
Anode or the target. And then what do you see? What happens when this
They reflect X-rays and electrons.
they fall on this, and then something is emitted, and that something which is emitted is known as the X-ray. Do we understand this?
Yes, sir.
Have you drawn this diagram?
1 second.
I'll give you time to draw this diagram. I'll give you a minute to draw this diagram. Drawn the diagram, bacha? This is not the main diagram that we are worried about. This is the diagram just to explain what is happening. And then the next Coolidge tube or Coolidge method comes, and Coolidge method is your main thing. We have to draw the diagram of the Coolidge thing as well. Have you drawn this?
Yes, sir.
Yes, sir. No, sir. Then, sir, what happens, sir? So this is the Rowington experiment. Now, what is Rowington experiment? What did he discover? He discovered that he has a tube, sort of a vacuum tube, which has a very low pressure inside. The pressure inside this tube is around 10 raised to the power minus 3 mm of Hg, which is very less, which is very close to vacuum. Do we understand that?
Yes, sir.
Then we have applied a very high voltage at the cathode. Yes or no?
Yes, sir.
Then when this high voltage is applied, some unknown radiations were coming out, and these unknown radiations are known as
X-ray.
because he did not know what to name them. And as we do in maths, if unknown quantity is named as X, comes the name of X-ray. Do you understand this?
Yes, sir.
Now from this experiment, we can understand 3 points, and these are the 3 points on which the entire X-ray theory is based. And all these 3 points, every question that comes on X-ray will be based. What are these 3 points? What do we know? Well, what do we need to produce X-ray? We need someone to produce electrons. Yes or no?
Yes, sir.
Who is that someone here?
Cathode.
Cathode is the someone here. Next thing. Means of accelerating these electrons, because these electrons has to strike the anode with very high speed. So I need something that accelerates these electrons. Do we understand this?
Yes, sir.
And the third thing is obviously a target where they are going to hit, and from where X-rays are going to be produced. So these are the 3 things, and on all these 3 things, everything, all the theory of X-ray is based on. I'll give you a minute to write it, and then I'll move on to the better arrangement, which is the Coolidge tube. And then we will understand this Coolidge tube in great detail. This was what Royinton did. And from Rowington experiment, we understand we need 3 things. 1 is a source of electrons. Number 2 is a means of accelerating these electrons so that they move at high speeds. The third thing is somewhere where they can hit, so that X-rays are released. Have you done this? Yes or no? Mare? So much time.
Sir, 1 minute.
1 minute. A minute to win it. Okay. I shall give you that minute to win it. And again, I'll be sending this sheet. I hope this sheet finds its way. Yesterday night, I was very busy. Could not send this sheet yesterday night. So I'll send it just after the class. And I hope this sheet finds its way onto your study tables.
Completed, sir.
Completed, sir. Then, sir, the next heading, sir, happens to be the Coolidge experiment or the Coolidge tube or the Coolidge method of producing these X-rays. And we have now a very detailed diagram, which you can see on the right-hand side, which I am going to do what? Which I am going to obviously, make it big and show it on your screen so that you can make more sense of it. This is the diagram. I hope you can see the entire diagram. Yes or no?
Yes, sir.
Yes, sir. No, sir. Then, sir, try to make me understand, sir, what is happening here, sir. Tell me what is happening here. Do we see what we have to see? Do we see a cathode here? Yes or no?
Yes, sir.
Where is that cathode, sir? Tell me, sir.
Left side.
Cathode is C. Do we understand this? Yes or no?
Yes, sir.
Do we see an anode here, sir?
Yes, sir. Right, sir.
Yes, sir. Right, sir. This is the anode, sir. Two things are there. Cathode, anode is there. Do we see a target here, sir?
Target. Yes, sir.
Yes, sir. No, sir. Where is the target there, sir?
T, sir.
T, sir. T, sir, is the target, sir. I am not going to draw it. Otherwise, the diagram may look very cumbersome. Okay, T is the target. Do we see the target?
Yes, sir.
Yes, sir. Then there must be a potential difference between cathode and anode, because we want to accelerate the electrons. Do we see that potential difference between A and B? Between cathode and anode? Do we see that? How we have created a potential difference? Have you seen that? Do you see that?
Yes, sir.
Where, sir? It is here, sir. Do we see this, sir? Do we see this, sir? Yes, sir. No, sir.
Yes, sir.
You see this, sir?
Minus. Yes, sir.
Yes, this is the potential difference that is created between the cathode and the anode. Now, we have cathode, which is our source of electrons. But how are these electrons emitted is the next question. How are these electrons emitted? The answer is right there in front of your eyes. Can you tell me how these electrons are emitted? A minute.
Water.
Water? Huh? How will electron be emitted from water? You put water, electrons will be emitted, eh? No. Think again. Do you know what this symbol means?
Filament.
Yes, what is a filament? It is nothing but a heater, something that you can heat up. So you have a cathode. Now, to emit electrons from any body, what do you need to do? We did that in photoelectric effect. What we need to do to emit electrons from a body?
Supply energy.
You know it from chemistry also. Yes.
Yes, sir.
What, sir?
Energy.
What?
Energy. Supply heat.
So, we need to?
Supply heat.
No, we need to give it energy. We need to give it energy. Ionization energy, work function. Do we remember this?
Yes, sir.
We need to give the electrons sufficient energy. Electron is like the child and nucleus is like the mother, father. They are holding the child together. Do you remember that story?
Yes, sir.
Yes, sir. That story comes here, sir, because that is the story of your life, sir. It again comes here, sir. So this mother, which is the nucleus, is holding the child, which is the electron. Someone has to give it energy. In photoelectric effect, who was giving it that energy? Are? In photoelectric effect, who was giving it the electron energy to go away? See, sir, we have forgotten it, sir.
Photons.
Only 2 days, sir. Photons. Photon had energy. That energy was, if that energy was more than work function, electrons were getting emitted. Yes or no?
Yes, sir.
Here, how do I get this energy? How do I get this energy? Here I get this energy by?
Filament.
By?
Filament.
By heating this cathode. Or you make the filament as your cathode and you heat that filament. If it gets enough heat, it will emit electrons. This type of emission is known as thermionic emission. This type of emission is known as?
Third ionic emission.
अबे थर नहीं, therm from heat, therm. We understand this?
Therm.
Ionic emission. Do we understand it now?
Sir.
Sir. Yes, sir. It's known as thermionic emission. So basically what we are doing here is we have a filament. And we are heating up that filament. And when this filament gets heated up, it starts to emit electron. Do you understand this?
Yes, sir.
Now to heat this filament, what we got to do, we also need to give it some voltage. Yes or no?
Yes, sir.
So, sir, that voltage, sir, is drawn here, sir. Do we understand this, sir?
Yes, sir. Yes, sir.
This is the voltage that we are giving to the filament, or you can call it the filament current, IF. This is the current that flows into the filament. If I have more current or more voltage in the filament, what will happen?
More energy.
Arey gadre. How more energy? If I give more current in the filament get heated up more. Yes or no?
Yes, sir.
So what will it do? I am very hot now. So I am babbling. I'm speaking loudly. I am spending more energy in speaking loudly. When the filament gets heated up more, what does it do? It gives you more. It gives you more what?
Energy.
Huh?
Energy.
Not energy.
Heat.
It gives you more heat. When it is more heated, it gives you more heat. A third standard student can tell me that. See, when you heat a filament, you get electrons. Do we see these electrons here? These chota bachas. Do you see these bachas which are coming
Yes,
out?
sir.
Yes. If I heat it more, will I have more bacha or less bachas?
More bacha.
More bacha. So if I increase the filament current, I will have more electrons. Yes or no?
Yes, sir.
This is what you need to remember about this. More the filament current, when IF filament current increases, the number of electrons increase. Do we understand this? Yes or no?
Yes, sir.
Yes, sir. Everyone, please raise your hand, sir, that we understand this, sir. When the filament current increases, filament voltage increases, I have more bachas, I have more electrons. Yes or no?
Yes, sir.
Okay, sir. Now let us look at the second point, sir. I have missed one thing. So I have a cathode, filament. To heat that cathode, to produce electrons, I have current. I have seen what happens with that current. Then I have anode, then I have these electrons which are bachas, which are trying to strike. Then I have an anode which has a target. This target will release X-ray. Do you see that jig 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 going out? This jig 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 jig.
Yes.
Do you see this jig 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 jig?
Yes, sir.
This jig 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 is the X-ray. Okay.
Sir.
But then what will happen is this target will be heated up because very fast moving electrons are striking it. Yes or no?
Yes, sir.
And that is why we have water. What is water doing? It is not giving you electrons. What is water doing here?
Controls heat cooling.
Yeah. Not controls it. It cools the target. It cools the anode. It cools the target. Do we
Cooling
understand
target.
this? This is the cooling agent. Water. I am also heated up. So I'll have some water. Water. It cools me down. Yes or no?
Yes, sir.
You have 1 minute, sir, to show me your talent, sir. To write everything that is on the board, sir. Please go on, sir. Happy birthday, sir.
Thank you, sir.
Why, sir? Is it your happy birthday really, sir?
Yes, sir. Yesterday.
Yesterday? Oh, so belated happy birthday, bacha. What's your name? Sorry, I don't know your name, sir.
I am Uday, sir.
What, bacha?
Uday.
Uday, so what did you do last night? Party?
Nothing much, sir.
Nothing much? Cake?
Just cake and.
Okay. Cake is good enough. You can't party, you're not old enough to party. You're not 18, right? So you can't party.
Yes,
It's as simple as that. Anyways, once you get into a medical college, you can party all day, all night. Have you drawn this diagram? Yes or no?
Sir, we are on it.
We are drawing. Okay, sir. Then I'm waiting. I'll give you a minute. Till then, I'll cool down. Yes, sir. We have drawn the diagram, sir.
Done, sir.
Okay. So we understand anode, we understand target, we understand water. What is water doing? The only thing we have not
Cooling the
understood.
target.
Yes, bacha.
Water cooling the target.
Water is cooling the target. Because if the target gets heated up, it will just start to melt, right? We don't want that. We don't want a melting metal inside a Coolidge tube. This entire jig 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 that is shown here is the Coolidge tube. Do you understand this?
Yes,
Just
sir.
change the color. So this entire thing is the Coolidge tube. Do you understand this? Entire
Yes, sir.
picture is known as the Coolidge tube. Okay, the only thing that we have not discussed is the thing in yellow, and which is the potential difference between the cathode and the anode. Now, you already know what this potential difference does. Tell me, if I increase the potential V, remember, in first case, I increase the filament current. When I increase the filament current, I have more electrons being ejected from the cathode. Do we understand this?
Yes, sir.
Now, if I increase the voltage V, which is the voltage between the cathode and the anode, I make cathode more negative, I made anode more positive, then what do you think will happen? If I increase the voltage, what will happen? If I increase the voltage, what will happen? If I increase current, more electrons will be ejected. If I increase the voltage, what happens? It's very simple. It does not require much much. In Hindi, there is a word called much, which I am doing right now. And somebody is troubling you, we call it much mat kar yaar. Don't do much. So what much you should do here? Tell me. What happens if I increase the voltage? What happens, Jaldi? I don't have the entire time in the universe to discuss this. What happens if I increase the voltage? More voltage means what? Are? If I have more voltage, what do these electrons have when they are moving? What they have?
Speed of electrons increase.
When electrons are moving, they have speed. When they have speed, they have kinetic energy. More kinetic energy means they have more
speed.
energy. If I increase the voltage, then what happens, beta? Simple. They will have more.
Kinetic energy.
Yes, they will have more energy. So the kinetic energy of the electrons increases, or the energy of the electron increases, or the electrons are going to strike the target very fast. Do we understand this?
Yes, sir.
If you have understood this, congratulations. The entire theory of what? Of X-rays and its protection is clear to you. Two things you must understand. What happens when you increase the filament current? You have more number of electrons. What happens if you increase or change the voltage between the cathode and the anode? And if you recollect, in photoelectric effect, we also had two things. One was the intensity of light, which depends on what?
Number of photons.
Number of photons. Intensity of light, I, intensity I depends on number of photons. Current I depends on the number of electrons. Does it make it easier for you to remember, or does it confuse you?
Yes, sir.
Yes, sir. I for intensity, I for current. Their intensity depends on number of photons. Here, the intensity, here the current depends on the number of electrons. Do we understand this?
Yes, sir.
Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir. No, sir. Then, sir, come to the second thing, sir. There also we had kinetic energy, or energy of photons. Energy of photons depends on the frequency of photons. Here we have kinetic energy of electrons, which depends on
Current. Current.
it depends on the potential difference between cathode and the anode. Do we understand this?
Yes, sir.
Kinetic energy of photons depends on the frequency of photons. That must be more than the threshold frequency. Here, the kinetic energy of these electrons, how fast these electrons are moving, depends on the potential
Potential
difference
difference.
between the cathode and the anode. Do we understand this?
Yes, sir.
So this is how I have related photoelectric effect with this X-ray, and I think since we have done both very close to each other, and that is the reason I have done X-ray today. I was supposed to do something else, but then in the morning when I got up, I got this idea, why not do X-ray today? So here's X-ray. I'll give you a minute to write everything. Obviously, do not write this gitch much in your notebook. And if you write this like this in your notebook, you may not understand at the end of the day what is there, because I have only drawn arrows and written nothing. So you write it in your own nice handwriting, which I know is obviously going to be much better than the much that I have created. So I'll give you a minute to win it. Once you are done, please let me know that you are done so that I can move ahead in life. Remember what we are doing. It may look like theory to you, but tell you very frankly, this is not theory. Same question will come to you in the examination hall, and then you will remember me, sir ne aisa hi bola tha. Sir said the exact same thing, and that has come as a question in our examination hall. Jai ho sir ki. But don't do jai ho sir ki at that point in time, because you have to complete the entire paper first. Do that paper first. Jai or no jai doesn't matter. The only thing that matters right now is that you understanding what is happening in the class. Tan, tan. A minute to win it. Have you noted this down, bacha?
Done, sir.
Done, sir. Then, sir, this, sir. This is the Coolidge method, sir. What is happening in this Coolidge method? Coolidge developed thermionic vacuum X-ray tube. Do you understand the meaning of thermionic?
Sir.
In which electrons are emitted or produced by thermionic emission method. Do we understand this?
Yes, sir.
Heat the filament up, electrons are emitted, thermionic emission. Due to the high potential difference, electrons which are emitted move towards the target. Do we understand this?
Yes, sir.
Yes, sir. Then, sir, what happens, sir? They strike the atoms of the target, due to which X-rays are produced. Do we understand this?
Yes, sir.
Electrons strike the target, X-rays are produced. We understand this?
Yes, sir.
And remember, very important point here, only 1 to 2% of the kinetic energy is used to produce X-ray. Where does the rest go? The rest is lost in the form of heat. So this target is going to get very hot, more hot than what I am right now. Red hot, green hot, Vibjor hot. How do I cool it down? How do I cool it down? Cool.
Water.
Water, cool. Do we understand this? Yes or no?
Yes, sir.
Yes, sir. Then you have 1 minute, sir, to write this entire thing, sir, in whatever short form you can, sir. You will be getting this sheet, I know, but once you have written material sheet, it's of no use to you. You only use it in dire straits. SOS, you only use when you have nothing. You have not written any notes. Then only you look at the sheet that is given to you, because the words that are written in the sheet are written by someone else. The notes that are written in your book are written by yourself. Someone else and yourself makes a difference here. Whatever you write, you'll always remember that you had read it. And that will give you a lot of confidence. A minute to win it. Write it fast. Your writing speed must be fast. The writing speed is slow. God help you. Let not God get into this picture, because God is busy with so many things that he has to deal with. A war is going on in Europe. He has to deal with that. COVID is happening in some other part. He has to deal with that. He has got no time to come and attend to your exam. We understand this? Yes or no?
Yes, sir.
We will have to do it all with your own hands, bacha. Even Ukraine is fighting on its own. No one is helping him. No God is coming there. God is still there. That's why they are surviving. You understand this?
Yes, sir.
Yes, sir. No, sir. Then fatafat, sir. Do the job, sir. 1 minute, sir. Not more than that time, sir. Because we have to move ahead in life, sir. So we have understood the entire process of producing an X-ray. We have a filament, which is the source of electrons. I heat the filament. I have electrons. More the filament current, more the number of electrons. These electrons are accelerated by the potential difference. More the potential difference, more is the kinetic energy of the electron. They strike the target. 1 to 2% of the energy is converted into X-rays. The rest of them is going to heat the target metal up. So I have water to cool it down. Yes, sir. Written, sir? Written.
Done, sir.
Done, sir. Then, sir, these points are characteristics of the target. What should be the characteristics of the target? You have seen this target is subjected to do immense things. So what are the characteristics of this target? And everything comes logically. The first point is the atomic. Oops. What has happened here? The first part is the atomic number should be very high. Why do I need a high atomic number here, sir? Why do I need a high atomic number here, sir? Why? Array?
More number of electrons.
More number of electrons. Yeah. And we will understand why more number of electrons. If it is a high atomic number, it will have more number of electrons. And what happens when these electrons are, remember, these electrons are in the target. These electrons are getting struck by the beam of electron which is coming from the anode. More is the atomic number, more will be the X-ray emitted. You understand this? That is why it needs to be higher. Do we understand this?
Yes, sir.
The thermal conductivity of the target should be high. Why I need it to be very good conductor? Because it is going to get heated up very fast. And I need to cool it down very fast, else the metal will start to melt. Do we understand this?
Yes, sir.
The melting point should be high. If it does not have a high melting point, it will melt, and you will have metal coming inside the Coolidge tube, and it will not become a Coolidge tube. It will simply become a metal tube. Do you understand this?
Yes, sir.
A minute to win it. Note it down.
Done, sir.
Done, sir. Then, sir, we have X-rays, sir. Again, You can see the similarity between this X-rays and that photoelectric effect. And that is going to be very clear from the next heading. Now, once you have this X-rays, and which you will be, some of you would be using it probably. If not using it, you must be using all these X-rays to see all this, what is inside the human body. Now, what is inside the human body? To understand it, you must understand what an X-ray is. Now, X-ray also has two types of things that you are worried about. The first type of thing that you're worried about in the X-ray is what is the intensity of X-ray. Do we understand this? What is the intensity of X-rays? Now, whenever I talk about intensity, it means the number of X-rays or how many X-rays are being produced. Do we understand this?
Yes, sir.
Now, how many X-rays will be produced or the number of X-rays will depend on what? It will depend on the number of electrons striking the target, yes or no?
Yes, sir.
More the number of electrons striking the target, more will be the X-ray which will be produced, yes or no?
Yes, sir.
This number of electrons which are leaving the cathode depends on the temperature of the filament, yes or no?
Yes, sir.
Now this can be controlled by controlling the filament current, yes or no?
Yes, sir.
So I increase the filament current, the number of electrons will be increased, yes or no?
Yes, sir.
If the number of electrons is increased, the intensity I of the X-ray will increase, yes or no?
Sir.
And that is what you are going to write in simple language or in this complete language. You write everything and we are done. Filament current, what is the what? What is the effect of filament current on X-rays? It controls the number of X-rays. Remember, intensity of X-ray stand for the number of X-rays. Do we understand this?
Yes, sir.
We have discussed this in photoelectric effect. Yes or no?
Sir.
Then, sir, you, sir, have 1 minute, sir, to write everything that is on the board, sir. I hope you will not what? Disappoint me, sir. 1 minute, sir, and you will be able to write it, sir. Remember, every question that is going to come on this X-rays will be based on this. Simple things. If you've understood this, that is why I'm talking so much. So that the more I talk, maybe this thing just gets into your head and you are able to give the answer when it comes, when it matters.
Done, sir.
Done, sir. Then, sir, the next thing, sir, would be the energy of this X-ray. Yes or no? One is the number of X-rays, the other one would be the energy of X-rays. Yes or no?
Yes, sir.
So basically, instead of calling it the energy of X-rays, we call it the penetrating power of the X-ray, which simply refers to the energy of X-rays. Yes or no?
Yes, sir.
Now, bacha, you know, how can I have more energetic X-ray? Tell me, how can I have more? To have more number of X-rays, I have to change the filament current. To have more energy of X-rays, what I need to do?
Apply more potential difference.
Yes, bacha, because if I apply more potential difference, I will have more energetic electrons. If I have more energetic electrons, I will have more energetic X-rays. Do we understand this?
Yes, sir.
Yes, sir. Then, sir, I will, sir, mark it, sir, on the sheet, sir. The penetrating power of the X-ray, which is the energy, depends on the energy of the incident electron. The energy of the electron can be controlled by controlling the potential difference. And hence, the penetrating power or the energy of the X-rays depends on the applied potential difference. Do we understand this?
Yes, sir.
And, sir, the main point, sir, Here, sir, remains, sir, that the intensity of X-ray, which is the number of X-ray, depend on the current to the filament, while the penetrating power depends on the applied potential difference. If you understood this, you would have done almost 90 to 95 to 98 to 99% of the questions that are going to come on X-rays. A minute to note it down, a minute to show me your talent.
Done, sir.
Done, sir? Then, sir, this thing, sir. Again, this is of more use to you guys. Two types of X-rays will come across. One is known as soft X-ray, soft. One is known as hard. One, what do you mean by soft X-ray and hard X-ray is very simple. Soft means it has less energy. Hard means it has more energy. Do we understand this?
Yes, sir.
And how is energy related to wavelength? It is inversely proportional. Yes or no? More wavelength, less energy. Do we understand this?
Yes, sir.
If you don't remember this, you can still remember this. Energy of any wave is directly proportional to its frequency and it is inversely proportional to its wavelength. Yes or no?
Yes, sir.
That means soft X-rays will have more wavelength and less frequency. Do we understand this?
Yes, sir.
Whereas your hard X-ray will have ulta of this. What is the ulta of this? Less wavelength and more frequency. Do we understand this?
Yes, sir.
And do we see this in the wavelength? Now this table may come to you as a straightforward question. What is the wavelength of the soft X-ray? What is the wavelength of the hard X-ray? You have to remember it. How much energy it has? 12,400. You remember this 12,400?
Yes, sir.
H into C, HC by lambda. Yes or no?
Yes, sir.
That is same, sir. That's why, sir, photoelectric, sir, and this, sir. The energy of this gentleman is also the same. Penetrating power, if I talk about less and more, why penetrating power is less or more? Because energy is less here, energy is more there. Yes or no?
Yes, sir.
What is the use? Now you know the use for radio photography, and I don't know what this means. Maybe 5 years down the line, you will tell me what this is. The next one is radiotherapy. I still don't know what it means. Probably you will be able to tell me what it means. A minute to minute right now. I hope you will note it down. Do we understand this?
Yes, sir.
Next question, sir. Let me see who gives me the answer for this one, sir. And the question is right here on your screens. 50% of the X-ray coming from a Coolidge tube is able to pass through a 0.5 mm thick aluminum foil. Potential between the target and the filament is increased. The fraction of the X-ray which passes through the same foil will be.
Option
50%.
sir.
Less than 50, more than 50, zero. Yes.
More than 50.
More than 50. What makes you feel that? More than 50.
More potential difference.
So more potential difference means what?
More energy.
More X-ray. So more X-ray means the percentage will also increase. So give you an example. This is a sheet. 50% of rays are passing through this sheet. I increase the number of rays. Will more percentage of rays pass through the sheet?
Yes, sir.
Yes, sir. No, sir. Your logic is flawed, sir. To make it pass through aluminum foil, bacha, you need more energy. So if I have more energetic X-rays, then only I will be able to pass on more percentage of X-rays. Do we understand this? Yes or no?
No, sir.
No, sir. Percentage, sir. Think about the percentage, sir. Don't think about the number, sir. If 50 X-rays are falling here now, unable to pass. If I increase the number of X-rays, the number of X-rays will increase, but the percentage of X-rays will not increase. Do we understand this? So if 100 X-rays were starting away and 50s were able to pass, if I make that at 200, now only 100 will pass. Yes or no?
Yes, sir.
So 50 to 100, the number has increased, but has the percentage increased?
No.
Because the percentage of X-rays which will pass through this sheet of paper depends on the energy of the X-rays. If I don't change the energy, how do I change the percentage number? Yes or no?
Yes, sir.
Have I changed the energy of the X-rays? Have I changed the energy of the X-rays? No, sir. I have only changed the number of X-rays. I have not changed the energy of the X-rays. And hence the answer would be
A.
A, number one, only 50%. Oops, what has happened here? Something has gone. Dung, 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 dung. Only 50. Oops. This is happening here. Only 50% will pass. Something wrong. I will just mark it from here. Only 50% will still pass. Because if I want more percentage to pass, I should have more energetic ones. If I have more energetic ones, then the more percentage will fall. Do we understand this?
Yes, sir.
Okay, sir. Then the next heading, sir, is the type of X-rays. Okay. You will say, sir, we have already covered type. There are two types of X-rays. One is the hard X-ray. The other one is the soft X-ray. Well, yes, you are right. This is the classification based on their energy. Do we understand this?
Yes, sir.
This is the classification based on their energies. Based on their energies, I can say one X-ray is soft, less energy. The other X-ray is hard, more energy. But this is not the only way in which they can be classified. They can be classified in a different way. Now, the different way comes because of the method of production of these X-rays. Now, we'll say method of production, sir. Right? What do you mean, sir? Do I change the target, sir? What? I mean, how do I explain the different X-rays by the method of their production? Method of production is same. For this X-ray, I need a cathode, I need an anode, I need electrons, and I need to make that electron move fast. That electrons moving fast will strike the target and X-ray will be produced. This is the method. Why different method? But there are different methods. And the first type of X-ray based on this method is known as the continuous spectrum of X-ray or continuous X-rays. We call them continuous X-rays. Tan, tan, tan. Now here is the diagram, and I can see the diagram is big enough for you to see. You can see this diagram, yes or no?
Yes, sir.
Now, sir, looking at the diagram, sir, just looking at the diagram and not seeing what is written in the side. So what I'll do, I'll just take this thing off and I'll only show you the diagram. Now, only looking at the diagram, can anyone tell me the diagram is right here? Oops, it has become too big. Okay, bigger the better. Bigger diagram. Now, looking at the diagram only, and obviously you need to draw this diagram as well. It's a very simple diagram. Looking at the diagram only, can you tell me what is happening here? Looking at the diagram only. Tan, tan, tan. What is happening here? Tan, tan, tan. Looking at the diagram only. What is happening here only? Can I have your thoughts, please? What is happening in this continuous X-rays? I would be very pleased if you can give me some thoughts. And again, if you can give me some thought, that means that we are understanding what is happening here. How are X-rays produced? The method remains same. We have what? Electron which is moving very fast. Do we see that electron which is moving very fast?
Yes, sir.
Where, sir? Here, sir. Do you see it, sir?
Yes, sir. Yes, sir.
This is the electron which is moving very fast. Then what is this K shell, L shell, M shell? What is this? We have drawn something. There is a plus sign in between. This is a plus sign here, as you can see. Then you have got all these small dots. Do you understand what is this? This is the target atom. Yes or no?
Yes, sir.
So it has a K shell, L shell, M shell because it is a electron. It's an electron. It's an atom with high atomic mass, atomic number. So it has more number of electrons. Jig, 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 all jig, 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 jig. Now what is happening with this jig, jig? Now if this electron, which has more energy, is passing, it will be attracted towards the nucleus. You understand this, no?
Yes, sir.
So it will lose some amount of its energy. Yes or no? As you can see here, it is entering here with a velocity v1 and it is leaving here with a velocity v2. Which velocity or which speed do you think is more, v1 or v2?
V1.
V1 will be more because it will be attracted and it will lose some amount of its energy. Yes or no?
Yes, sir.
Where does that energy go? It will go in the form of some radiation. Yes or no? Law of conservation of energy.
Yes, sir.
Energy cannot be created. Obviously, this will heat up the atom. Yes, it will heat up the atom. But some amount of energy will be going in the form of radiations. Yes or no?
Yes, sir.
And that radiation is your X-ray. Do we understand this?
Yes, sir.
X-rays produced in this fashion will have all wavelengths which are possible. All wavelengths which are possible because this radiation can have any possible wavelength. And therefore, since you get a continuous wave, you get waves of all wavelengths, you get X-rays of all wavelengths. This type of X-ray is known as what?
Continuous spectrum X-ray.
Yes, this type of X-ray is known as continuous X-rays or continuous spectrum of X-ray. Do we understand this?
Yes, sir.
So if this diagram comes in the examination hall and then they ask you what is the type of X-ray that is produced, what do you say? Continuous X-ray. Do we understand this? Yes or no, bacha?
Yes, sir.
Yes, sir. Then, sir, I hope you have drawn this diagram, sir. Drawn it or not?
Drawing, sir.
Drawing, sir. Should I make it big, sir, or is this enough, sir?
Enough, sir.
Enough, sir. Then, sir, After drawing the diagram, sir, you also write this, sir, the explanation of this diagram, sir. And what is the explanation of this diagram? The explanation of this diagram is pretty damn simple from where I see. When high-speed electrons collide from the atom of target and pass close to the nucleus, there is a Coulomb attractive force due to which the electrons is deaccelerated. The energy is decreased. The loss of this energy during deacceleration is emitted in the form of X-rays. The X-ray emitted in this way are known as breaking or Bremsstrahlung radiation and form a continuous spectrum. So you can call this by all these three names. In continuous spectrum of X-ray, all the wavelength of X-ray are present. Remember this, you understand this, yes or no?
Yes, sir.
All types of wavelengths are produced, but small thing. But below a minimum value of wavelength, there is no X-ray. So they have a lower limit. Below that limit, there is no X-ray. Do we understand this? So it will have all wavelengths above a minimum value. And that minimum value is known as
This wavelength of X-ray.
threshold wavelength. So there, see, you see, minimum wavelength, threshold wavelength, yes or no?
Yes, sir.
Here also, there was, here it was, here that was maximum wavelength, here it is minimum wavelength. Okay, threshold wavelength. This minimum wavelength depends on the applied potential. Do we understand this?
Yes, sir.
Why it depends on the applied potential? Because of the applied potential, you have energy, and energy is related to wavelength. Yes or no?
Yes, sir.
So in continuous X-rays, we have a minimum wavelength. All the X-rays are above this wavelength. This minimum wavelength is known as threshold wavelength. Do we understand this?
Yes, sir.
You'll have a minute to note this down. I'll give you a minute, 2 minutes. A minute is enough? Yes, sir. No, sir. Better I go, sir.
Yes, sir.
Yes, sir. X-ray, sir. I'll give you a minute. You understand this, bacha?
Yes, sir.
Have you written this?
No, sir.
No, sir. So much time, sir. Okay, sir. I have time. Take it.
Done, sir.
Answer, that is very good, sir. Now we understand, we have written that below a minimum wavelength, you will have no X-ray. Now let us see how does it come. And again, you may not remember the entire process. You just have to remember the final thing that we get. Are you ready?
Yes, sir.
So here comes, sir, what happens here, sir. So you understand what is happening here, sir. This is the initial kinetic energy, sir. Oops, sir, what is this, sir? This is the initial kinetic energy, sir. This is the final kinetic energy, sir. Change in kinetic energy. That will come in the form of X-ray and the heat energy, yes or no?
Yes, sir.
Now, if I take the final velocity as 0, that means the entire energy has been taken away, yes or no?
Yes, sir.
And we also assume that the heat, there is no heat loss, so we are taking the most ideal case, yes or no?
Yes, sir.
So instead of V1, we write it as V. V standing for velocity. Half mv square becomes h into f max, where f is the maximum frequency which is possible, yes or no?
Yes, sir.
This half mv square is also equal to E into V, because that is how it is getting accelerated, yes or no?
Yes, sir.
You can just write this equation number 1 and this equation number 2. Do we understand from where these equations are coming? We are assuming that the final velocity is 0, so the entire energy is lost, and we are assuming that there is no heat loss. Do we understand this?
Yes, sir.
A minute to write this. Everyone got this?
Yes, sir.
Yes, sir. Then, sir, from equation number 1 and 2, sir, this thing comes, sir. Do we see this? From 1 and 2, I can write. From 1 and 2, I can write H into F max is E into V, where V is the applied voltage, yes or no?
Yes, sir.
So from here, I can find out the maximum frequency that is possible. That will be equal to EV divided by H, yes or no?
Yes, sir.
And this is the formula that comes when you put the values of E because E is charge of an electron, and you put the value of H because H is the Planck's constant. This is the value that you get. Here you just need to put the value of V and you will get the maximum possible frequency of the X-ray. Do we understand this?
Yes, sir.
Now you have two choices. Either you can remember it in this form, which I think is easier to remember, or you can remember it in this form, where you can straight away get the answer by putting the value of V in volts. I leave it to you how you are going to remember it. If you can remember both ways, you will be able to solve the question in a flash. Flash is also a comic character which I love. You can move very fast. Flash. I love Flash. I love Flash. I've seen 3 or 4 seasons of that series. It used to come on some channel. I don't know. Flash. He moves faster than light, and it goes back in the past and does some very funny things. So that is how you can get the value of maximum frequency. Do we understand this?
Yes, sir.
If the frequency is maximum, then one thing becomes minimum. What is that minimum thing?
Wavelength.
Yes, sir. Then, sir, I put the value, sir, and I get the formula for wavelength, sir. Lambda minimum is SC upon EV. Do we understand this, sir? Do we understand this, sir, beta?
Yes, sir.
And as soon as we get HC by E, we arrive at our. Do you understand this, no?
Yes, sir.
Arrive at that 12,400 wala figure fit se. You understand this? And here it is also divided by E. So now it is not in volt, it is in now it is not in electron volts, it is in Armstrong volt. Do we understand this?
Yes, sir.
Here V is the voltage. So now I get that famous formula back again, 12,400. 12,400. Energy was 12,400 divided by lambda in Armstrong unit. You get the energy in electron volts. Now you are getting lambda from there. And that is how 12,400 comes back. Will you remember this 12,400?
Yes, sir.
And what value this 12,400 plays? Remember, minimum wavelength is in the case of continuous X-rays. Do we understand this?
Yes, sir.
You will have a minute to win it, and then I shall show you something else. Obviously, I'm not going to show you a song or a video clip. I'm going to show you a diagram. That's what I'm good at, showing diagrams. Comes the next diagram, and where you may find the maximum number of questions arriving. A minute to write whatever is there on the screen. Don't take more than that.
Done, sir.
Well done, sir. So you are improving, sir, and that is what I like, sir. Good, sir. Then, sir, come, sir. This, sir, can you make me understand what is happening here, sir? What is the graph drawn here? Between what and what? Here I have the intensity of the X-rays, and here I have intensity means the number of X-rays. Do you understand this?
Number of X-rays.
Yes. And the lambda, right? Now you see at different voltages, V3, we have some wave, some continuous X-rays. On V2, we have continuous X-rays. On V1, we have continuous X-rays. Do we understand this?
Yes, sir.
And here we have 3 different wavelengths. Do we understand this?
Yes, sir.
This is lambda 3. This is lambda for 2, and this is lambda for 1. What are these lambda 3, lambda 2, and lambda 1? These are threshold wavelengths. Do we understand this?
Yes, sir.
Now you can see V3 is greater than V2 is greater than V1. Since V is greater, therefore the intensity is more. Do we understand this?
Yes, sir.
But more potential, you have more energy. But here you see the lambda is less. Lambda is inversely proportional to wavelength. This is the diagram that is going to come. Thank me when you see it in the examination. You don't need to thank me. I'm just doing my job. My job is to tell you everything that can come in an examination hall. A minute to win it.
Done, sir.
Done, sir. Then, sir. This, sir. Very important point, sir. Just note it down. Continuous X-rays, we have shown it by different names, also known as white X-ray. Minimum wavelength of the spectrum only depends on the applied potential and does not depend on the target metal. This is the question that has come many times. So the continuous X-rays, even if you have iron as your target element, you have tungsten as your target element, you have any damn thing as your target element, continuous X-ray does not depend on your target. It only depends on the wavelength of this continuous X-rays. Only depends on
Applied potential.
applied potential. It does not depend on your target. You can have any target, but the minimum wavelength will only depend on the applied voltage. Do we understand this?
Yes, sir.
Yes, sir. Please note it down, sir.
Done, sir. Done, sir.
Have you done, sir?
Yes,
Shall I
sir.
move on to question, sir?
Yes, sir.
I have a question. X-rays obtained by Coolidge tube are done. Answer, sir. Answer, sir. Yes, sir. Monochromatic means single wave, and the rest of the options. Which is the correct option here?
B, sir.
A, sir.
B, Bombay.
What we have studied, sir, you have put it everything in the flush, sir, and flushed it, sir, out of the system, sir. We saw minimum wavelength, yes or no, sir? We just saw the diagram, sir, that below a minimum wavelength, every wavelength is possible, yes or no, sir? Yes, sir? Or no, sir? So the answer is what? The answer is C. Of all wavelengths above a minimum wavelength. Do we understand this?
Above minimum, sir.
Of all wavelength above a minimum wavelength. Do we understand this? Can I have some raised hand that we understand this? You just saw the diagram, yes or no? Above the threshold frequency, above the threshold wavelength, we have all the wavelengths of X-rays, yes or no?
Yes,
Girls,
sir.
please raise your hands. We understand this.
Yes, sir.
Girls, we don't understand. Please raise your hands. What's wrong in raising hands? Okay, nothing wrong in raising hands. So this is how things are done. Then comes the next question, sir. On increasing the filament current in X tube, what happens? Dung, 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 dung. Answer for this one, sir. For increasing the filament current in X tube, what changes? What changes? Array?
Sir, B, number of electrons increases.
What increases? Number of electrons increases.
Electrons.
Yes. So, what is the correct answer? Four options, yeah. See, you're all
Sir,
on the
D,
yes.
sir.
Huh?
D.
D. Intensity of the X-rays increase. We'll have more X-rays coming out. Yes or no?
Yes, sir.
Then, sir, this question, sir, that will finish what we have done in today's class, sir. Minimum wavelength, threshold wavelength of X-ray is 2 Armstrong units. Then what is the potential difference between the cathode and the anode? Cathode and the anode. Can I have the answer quickly first? $64 and $62 kilovolt. 6.2 kilovolt. 24.8 kilovolt and 2.48 kilovolt. What is the answer? We don't have the answer. Shameful. How do you get the answer here? Lambda minimum we are talking about. Yes or no? We understand this, bacha? Lambda minimum we are talking about, right? What is the formula for lambda minimum, beta? 12,400 divided by V. Yes or no?
Yes, sir.
So from here I can find out V. V is 12,400 divided by lambda. 12,400 divided by lambda, which is 2 Armstrong units, will give me 6,200 volts. Yes or no?
Yes, sir.
So what is the final answer for this question?
Option A, 62 kilo ohm.
If I divide this, 6200. If you're now going to tell me that 6200 means 62,000 kilowatts,
6.2 kilowatts.
well, not even God can save your soul. This is not expected. This cannot be done. You have lost 5 marks, bacha, and probably you have lost your college as well. Congratulations. You don't have a medical college now. On that sad note or exciting note from wherever you see and you understand what mistake you have made, we shall call it a day. And I hope what we are going to do when you are going to come in the class tomorrow, before coming to the class tomorrow, what you are going to do? Pray to God. Yes, that's one thing that you can do, but that's not going to help much. Yes, what is the next thing that is going to do to help you much?
Revise the notes.
And so that you can do much in the class, you have to revise notes, because in the next class we'll be winding up this X-ray, so we'll be moving ahead and doing one more type of X-ray, and probably we'll move on to the next topic as well. So we are running fast because these topics are very small. So we'll be winding up X-rays and probably taking on your next topic. What is going to be your next topic? That's a surprise. So we'll see that surprise, and I hope that you will get this note by today. On that note, I will wind up today's class. If any doubts, you are welcome. Take care. Bye-bye.
Bye, sir.